2. I skipped it so that we can finish. Okay, this is that page. So let's work this page now. Okay, let's work this page now. In groups of 3, everybody should be using the quiz near us. Do you have enough? What? By the way, and I am not being rude, but she'll scream at me. Yeah, the rule is, if you know how to do this already, because she's been with us for a while, then she can only ask questions, she can guide your thinking, but she can't tell you. Jen is the same way. They can ask questions, they can guide you, but you can figure that out. Let's go back to this.
So there's your recipe right there.
Okay, so find one of these.
They want to make it.
Oh, yeah. I had mine on my phone.
I thought it was ready, dark.
And ask the right questions. Jen has been with us for several years already, so if she already knows how to do something, because I've been quizzing her right several times, her role is to only ask you questions. She cannot tell you how to answer, but she can guide you to the answer. Picture all 3 of us touching the quizzing their rods.
I touched her.
Continually.
Well, no.
Continually.
So how did you get 7 at the top?
They said 14 total, 14 of these for the complete recipe.
So,
Ask me a question.
what represents the?
Oh, yes, this represents, but you don't have to, yeah, all of it, because I think you're gonna find it, yeah, all of it is. Yeah, I need to do both. I think
Wants to make how much?
So here is 2, and it's a recipe, so
Because we have purple. So you can convert this to a purple. Well, we don't have any more purple. There it is. There's that one. And then this one.
And this represents what?
that's exactly.
You're right.
Can we get another purple?
It's so easy to take what?
I know. Because I just want to.
You're the hardest.
Okay, show me with your fingers how many more minutes you need. 1, 2, or 3. 3. How many more minutes you need? 1, 2, or 3. You're done? 1 minute, yes. You got 1 minute. Okay.
So what is that? Yeah.
So she made this 2.5.
Just concept? Is that what you're talking about? Oh, it's just right. It's really bothering. Solar system is not to take 40 minutes. It's really bothering me, but if it were scale, we would have to have really big.
You're gonna be out in the street.
We would, several blocks.
Right now, I mean, that's a little bit, and I don't have that. That was one thing, and I would make sure. And then we would go somewhere else, and then we're.
The kids built the solar system, and we do the scale, based on the scale. But we have this line elementary, and line elementary is like 4 blocks for the administration building. Sometimes they would have all of the plans if they were at the administration. And it really got into the kids.
Make sure that
Huge.
when I go to scale, you can go to scale and size the actual.
Distance from the sun.
Right.
Yeah, we did that at the facility one time. Way out there, by the time we got the
And then
Pluto.
it says she makes 2.5.
Okay, so,
I need another one. Do I need more?
I don't know everybody's names because I'm really bad with the names. Is it Michael?
Mike,
Mike?
well, Michael, Mike,
Which one?
Mike,
So what is his name, Michael? He goes by Michael.
Michael works, Mike.
Mike, what was your answer, Mike? Give Mike our full attention.
Mike.
Okay, let's stay with him. There we go. Okay, so if we could give time out, ladies, gentlemen. When I'm talking, you have got to listen, okay? Because I say really important things, don't you know? That was a joke. So, when I call on a student to give the answer, you've got to stop and listen. I know some of you are still working on it, but we have limited time here. So you've got to stop and listen, okay? Because this is not the lesson, this is a review, remember? Yes. Okay, so Mike has the answer to this.
The 8 3/4 quarts is what we came up with for the total.
Okay, 8 3/4 quarts. Thank you for putting the unit on there. Toby, what did you get?
We got 8 3/4 quarters.
8 3/4 quarts, Tanya?
We're almost through.
Almost there, okay? Tim? Almost there, okay. So, what did you get?
UTN said it was 8.75 quarts.
8.75 quarts, oh my goodness, is he correct? What about that? Hey, Toby?
No, well, he's not incorrect, but he's not correct in the verbiage or the usage of the language.
Math academic language.
Okay, because, what did he say, Kim? 8.75? 8.75. What's wrong with saying 8.75?
It should be 8 and 7,500.
8 and 7,500. And why do we want to say it that way? Right, we have got to reinforce that place value. Many errors are made because kids do not understand place value. So in elementary school, up through middle school, you've got to reinforce place value. So don't allow your students to say 8.75 in math. They have to say 8 and 7,500. Now, Dr. West has informed me that sometimes science teachers say 8.75, which they should not do. I've threatened to spank her, but she runs away. But I realize sometimes a science teacher will say that. But if the science people could reinforce the place value, that would be very helpful.
Even in high school?
Even in high school.
So how do you, what do you suggest when using the calculator?
Oh, you did?
You can read it off the calculator.
No, when you're telling them to punch something in.
You call it a period and.
Okay.
That's what I tell my kids. Decimal, decimal point, decimal, and. Thank you, Tanya. Okay. Okay, we're gonna roll on now with a new lesson. Now, you know the difference in an activity and a lesson. An activity is part of the lesson. So I have a whole lesson today that has 6 activities. Okay? Part of these activities we're gonna do whole group. Part of these activities I'm gonna put you in groups of 3, I'm thinking, because of the numbers in here. Okay? So, this is on proportional relationships. Proportionality is the big idea in middle school, which now, with the revision of the TEKS, has moved down to elementary school. So proportionality is a huge things. Algebraic thinking includes a lot of proportionality thinking, so it's extremely important that kids develop this. It does not develop, according to brain research, it does not develop automatically. It has to have, the kids have to have experiences with this to develop this type of thinking. Does not develop, and I can tell you it does not develop automatically. My husband has none. No proportionality thinking. He's a history buff. He can tell you anything about history, but no proportionality thinking. So, let's work this. Every group worked the same problem here. I'm going to read it. The length of a model train engine is 2 purple rods. Okay? It's also 4 red rods. If a flatbed car, see it below there, measures 3 purple rods in length, how many red rods long is it? This is a brief activity. So at your groups, talk about it.
She's their, questioner.
Oh, yeah, because they're all new.
So you're there.
Okay, so that was
Okay, so both of these represent.
this one represents
These things do
6 of these.
what is on the board first.
Yes.
And then what was
They were flatbed, 3 purple rods, measures 3 purple rods. How many red?
How do you know what's this? Red?
So it would be, so one
Because it's like 1 purple rod is 4 cents.
So that would be a total of how many?
12.
12. So then if
just this one though.
2 divided by 12 divided by 2 would be 6.
Okay.
Show your thought process.
So if you had one, I determined it's 4
Show me with your fingers how many more minutes you need. 1, 2, or 3? 2? Okay, you got it.
4. Okay, there's one right there.
Your cowboys.
Three purple ones.
Yeah, that's me too. That's why I like that. And the other people well, that, but when we first went to the picture of it, they're right. This little, it's on the gun, this is my kids. I mean, at the first year, yes, but I mean, she's certainly, that's what she does, you know what I mean? Each team that will boost in their souls, you know, that, and she's
Football.
these are hard to get.
Next year, there's Henry Tom versus the Eagles, and you got, they have so much more to fight for people in the audience.
Okay, let's come together as a class. Craig, what was your answer?
The flatbed car is 8 red rods long.
The flatbed car is 8 red rods long. Thank you for using a complete sentence. Tanya, I'm sorry, I don't know y'all's names.
Anna,
Anna, thank you. What was your answer?
6 red rods long.
The flatbed trailer
Yes.
is 6 red rods long. Say that 3 times. Okay, so we have 8, we have 6.
We have 6.
Oh, I'm sorry.
No, you're right.
Anthony,
Six.
you got 6 red rods long. Craig, you want to rethink?
No, we have it. I just when I count, we have 6 right here.
So you had the 6, and then you just said 8.
6 what, Craig?
6 red rods.
Love.
I mean, we have 6 red rods for our 3 purple
Thank you.
rods.
Good. Thank you, Craig. Okay, so now you kind of understand what we're working with here. We're making trains. So, anybody want to share how you solved the problem? Lisa? Share?
So you're sharing because you
Oh,
spoke
yeah.
up.
Donna and I did it as a ratio, so we immediately put together our 3 little purple rods to represent the train engine.
Okay.
And then we realized, oh, 2 purple rods,
No, one purple rod.
well, I'm sorry, 2 red rods equal just 1. So then we decided to match them together like the kids would. They would kind of go, all right, well now I have it all together. So I can clearly count out each rod. So for every 1 purple, there's 2 red rods. So the answer is for every 3, or for the 3 purple rods, there is now 6 red rods to represent it equally.
Okay, and that was very well said, and modeled much like a 5th grade student would do it. We would want them to do it comparing the lengths. Did anybody do this a different way? Basically, you all did the same thing. Okay, great. Let's roll right along then. So you should, oh, where are my handouts, baby? Okay, so you have this table, and it says we're gonna fill it out together. However, I can't get the Elmo to work, so you're gonna fill it out together at your table. Okay, but quickly first. All right, and I wanna hear some discussion about it. Please don't use your teacher knowledge. Try to think as a child in the grade level that you teach. Okay? So Mike, what grade do you teach? 6th grade. You should be thinking like a 6th grader.
Okay.
And you're the principal, so think like a 6th grader. Okay? You're 5th grade, so think like a 5th grader.
Yes, I know.
Now, when we're filling out this table, what should we also be doing since we're 5th graders? Modeling with the Cuisenaire rods. Modeling with the Cuisenaire rods, because I don't want you to use your teacher knowledge. Think like a kid, which is difficult sometimes.
No, I probably should.
What do they mean about that? Doubling?
On this page, this is the same one, right? Right.
What's the one we just did?
Very observant in the mornings on Saturdays.
So, the first one says 2 purple rods.
But this is not the way that I understand
That's
it.
the
And that's
English
what
one.
time it is.
And that's actually how I have the kids.
Yeah, this throws them off with your formulas. I just had to, we had no area, we had to go into a whole other thing,
So the pattern is,
which I didn't realize until it was like, oh, right, y'all don't get this.
So what's the process?
You're a 5th grade, I'm not teaching.
Hey, let me backtrack, because they were just looking at me like, oh. Yeah, so well, it works out, because I saw the looks on their faces when I read that formula, I'm like, oh.
so you're adding,
You added the purple.
you're adding the multiple division.
And then divide by 2.
So, did you start with red rods or purple rods when you got into
In my mind, I started with purple, just total.
then when we got down
And I determined just, each of these had 2, so I divided by 2.
so if you're looking at this paper, on this one, this one,
Go back to that part.
and work toward this.
No.
Oh, no, you're right.
No,
And we divided.
Please don't confuse me, so.
started with the number of purple rods you had 2.
Well, actually, actually, maybe it wasn't multiplication, because I thought of all the total.
Because what I did was I looked at this, and then compared it to,
You did multiply.
Yes,
and that would be,
by their powers.
because you're increasing by 2.
So I guess it wasn't multiplying and dividing.
So show me, I see where you're saying to get that, show me where you're dividing. So I'm not sure I understand
The
that.
division was, you get a total of 12 of these, right?
But if you're dividing, you're going from this to this, correct?
You're undoing,
Now doing what you,
right?
yeah.
You see 12 total, right? What are these called, units?
Yes.
So 12 total, 7 units. And then I knew that those are 2, so I just divided that 12 by 2, and you get 6. So I had that this would be 6.
Oh, okay, so I think I see what you're saying. You're saying you, in your mind, put 12 of these together. So you somewhere down here. This number would be this X somewhere down here. And in order to find the number of red rods, you took the total number of purple rods
And
and
divided by
divided
this.
by two.
The red rod has 2.
Right.
So then I just knew that there would be 6 of them,
What would be 6 of those?
the total.
And then you'll do
The total of what?
That's what I thought she meant by, what do the kids do now? I'm like,
6.
talk and play.
They said,
So, X
Okay.
3,
times 2 equals 1. And you did the
that's all, right? So with 3, you know that this, each of these is 4, right? So that's 12, so that's multiplication. Then you get your total, 12. Then I knew that these are 2, so then I just thought 12 divided by 2 is 6. There must be 6 in each of these.
And does that
You
make
grab
sense
6
here?
of these and bam.
Okay, I see what you're saying when you say that
Oh,
right now. So
as you're
what you're
adding
doing,
on.
you're not looking at the rod as a whole, you're focused on each of these.
And then you fit it to the, whatever it is.
I don't know how to put it into words.
Well, actually, what
So
is
then
this
you-
fit? So,
Would you call that
The way I looked at it,
the
Multiplication
units?
and division. Multiplication.
Right, so I see what you're multiplying.
yeah, because
Where
then
are
if
you
you.
guys?
or 3 more minutes.
You got down there.
You got 12 of these, right?
Or should I say
This is
X
2.
plus
See,
1?
I don't, the way I looked at it,
That
is
is,
look,
this is actually one red rod. So, but it has 2 units. So I knew 2
If
times,
you have 12,
to get 12, that's 6.
so if I go.
so how would you have your kids write that process?
I don't know.
I told you earlier,
But you can totally do this, but
so X,
And read that.
X plus 1.
if you think of whole rods,
Where are you getting
what would
plus
you
one?
do? I mean, if you had, okay, so
So
3 whole purple rods is equal to 6 red rods.
that you see,
So if
but
you
you
don't
don't
break
write
it down
an
to
equation, you
individual
just write a
units,
relationship
well,
with the number of red
So
rods.
then what you have to do,
Okay, so
I guess,
let's start from
is
there.
group these in
What pattern do you want to
2, 4,
And then
2,
can you
4,
put it
6.
into words as I'm adding,
Match these
as I'm adding 1,
like this.
then my answer is
okay, so then 1 purple rod is equal to
increasing by 2.
red rods.
So then you would know that this is 1, 2, 3, and this would be 3 times 2, would be 6.
What pattern do you what are you doing? I'm adding 1,
Multiplying times 2.
then my answer is 5.
Well, that's how it is. That's how it is.
Right, but if this is the
Oh,
parameter,
why?
you were doing it like sport. I were doing it with kids like you were.
This is 6
I
times.
would say here, the total length of purple rods equals,
Get your units, so you figure out the number of units of 12.
well, the number of units of 4 is, that is, this is a unit.
So 3
This
times
is the
4.
first step.
So then
But
it'll
if
be
you
4
don't,
times.
I guess why too is depending on what you're calling it. Because in my mind, unit is something, right? But if you're saying this is actually,
That's how I'm adding
Yeah, I said you started
yours is
lower.
up this,
by 1.
which makes sense too.
This is increasing.
So then you would basically, the
Pattern,
total,
okay.
No, this
and then I think division would be what you would do.
Would not correlate.
So you would double it.
That's what I'm saying. Well, differently down here, wasn't it? Because how many purple rods do you need to have?
Reversal because you're going in order 1, 2, 3, 4. Your pattern is.
I keep trying to.
Well, purple rods.
Okay, so
That's
they're
what-
talking about,
Then
okay, so
why
what's the difference between a
will
unit and a
increase
rod?
by 2? Is that what you're
Well,
saying?
this is a rod made up of.
1, 2, or 3.
Okay, I see.
One more minute.
But that was
Yes,
really.
units are.
And see, and I'm not trying to go down.
We're teaching this right
You're familiar with what they said, right?
Oh, and I already did that too.
So it's.
Well, but what's funny is how our.
X times 2 equals y.
They always don't say what you have.
X times 2.
When you were reading, this right here is that. Now you wanna look at this one. So what's happening with this?
So then if I had
5.
So,
Just look.
for 12.
Okay, if we can come back together as a group, we can come back together as a group. I'm assuming that, what did we put right here?
5
5. What was your process?
times 2.
Times 2.
What times 2?
5 times 2.
2 times 5, 5 times 2. Why did you put that here?
It's for every.
The next purple rod, and we're adding one, the pattern on the purple rods is to add one more purple rod.
For the pattern. You notice the pattern here, the pattern for the purple rods, they're doing what?
They're adding one more purple rod.
They're increasing by 1 every time. Increasing by 1 every time. Okay, so we're assuming this is 5, we're pretty sure it's 5. And so this would be 2 times 5. Where'd you get the 2?
The two red.
Two red rods make one purple rod.
2 red rods make 1 purple rod. Perfectly stated. Perfectly stated. You did not say it was because it was in the table already. Right, now kids are gonna say that. Kids are gonna say, well, that was a 2, that was a 2, that was a 2, so it's 2 times 5. And it's good that they notice that, but you want them to rephrase it into the actual rods that they're using. Make it make sense with the manipulative, not just looking at a pattern in the table. It's gotta make sense with the concrete manipulative, okay? Because I'm gonna tell you what happens. Kids grow up and graduate from high school, they can't read a graph because they can read the graph, but it doesn't make sense to them because they cannot relate it to what the graph is talking about. Like people in cars or students in buses, you know, that kind of thing, okay? So if this is 2 times 5, the number of red rods then would be?
10.
10, good. So I'm not gonna go through the whole table since I don't have it on the L note. So down here, we called this X. We called the number of purple rods X. Is that okay? Can we call it X?
Yes.
Could we have called it A?
Yes.
Or could we have called it T?
Yes.
So why can we call it anything we want to?
Because we don't, it can be any number that you would like it to be. You can have any number of purple rods. That's what the letter represents, whatever you want it to be.
So the number of purple rods can vary,
Yes.
so we call it a variable. Okay, call it a variable because the number of purple rods can vary. So whatever X is here, it's 2 times X to give us, and we chose to put Y here. Normally, the 2 letters that we use are alphabetically, you know, XY, AB, ST, PQ, something like that, okay? They're alphabetically. And usually, the first one alphabetically is the X value, and the second one is the Y value. I'm sorry, I'm doing teacher talking now instead of kid talking, okay? So back to kid talking. No, let's go to teacher talking. Why is this table so important for kids? Tables are so important for kids to learn.
Visually, they can see how it's written and they can see the pattern.
Good. Visually, they can see how it's written and pick out patterns. What were you gonna say, Mike?
I was gonna say, see the patterns.
And patterning is so important. That table back there, Sonia's table, had a really good discussion about patterns. Anna, you wanna tell us what you did?
For A, the patterns that I observed was that as X increased by 1, then Y increased by 2.
Right, as X increases by 1, Y increases by 2. That's a great sentence to describe that. Great sentence to describe that. Now, the pattern that she noticed is going down the table, going down the chart. That's called a recursive pattern. You have to know the one before it before you can get to the next one, the next one, the next one. It's recursive. It's repeated addition. It's recursive. we want eventually the kids, and if you've read the new revised sheets, 5th grade, you know, y'all are doing this too. Eventually, we want the kids to see a pattern across a table. So, I'm sorry, I forgot your name.
Brenna?
Brenna, can you tell me what pattern you noticed across the table?
I noticed the X was always doubled to get Y.
X is always doubled to get Y. So our process here is 2 times X equals Y. That's called, now the kids don't have to know these names, but that's called an explicit pattern. Explicit pattern. So if we know the explicit pattern here, we know how many red rods it would take if X were 1,000, right? How many red rods if X was 1,000? 2,000. Now, do we want to create a table that goes to 1,000 and use that recursive pattern? No. But in the beginning, the kids are going to use that recursive pattern, and that's absolutely okay. But eventually, you want to get them over to that explicit pattern because we're building to functions. Okay, we're building to functions. All right, algebraic. Okay, good job.
Wait, so Miss Brown,
Yes, sir.
you're asking what makes it confusing?
Yes.
And I was looking at it, and first when I wrote my equation, and then Toby wrote his equation kind of confused me, but then when I thought about it longer, then we figured out the right one. But I think the reason why I got confused was because on the bottom where it says 2x equals y, some students are thinking that that's 2 purple rods equals 1 y.
Okay.
And it's really 1 purple equals 2 red.
And that's a good point. Would you repeat that again? Can y'all tell me what he said? He's
So
down
on the
here.
bottom, where it says the process is 2x, and then it says 2x equals y. And then on B, it says write an equation to describe the relationship between the number of red rods and the number of purple rods. It's really 1 purple equals 2 red. So that process next to that y,
Are you sure? 1 purple equals 2 red? Get your one of those printer rods out and see. 1 purple equals 2 red?
yes.
Okay.
But on there it says 2x equals y, so people are thinking 2 purples equals 1 y. Or that can be confusing for students.
What do y'all think?
At the time.
Is this 2 purples?
No, it's 2 times purple.
Is it 2 purples or 2 reds?
2 times the number of.
It's
2
1
reds.
purple, 2
Times
times.
the number of purples, which is different than 2 purples. 2 times the number of purples should give us the number of reds. Is that correct?
Yeah.
Okay, is that what you two, Toby and Chris?
Yeah, I'm still fuzzy about that. What I would want to do then, if I were to say 2p equals 4 r for red,
Really?
well, then I would want to simplify that equation to where I can come out to where it would be, if it's y inside by 2,
Right.
then I would come out with 1 purple equals 2 red.
Okay, and that's correct, isn't it? If we back up here, if we subtracted the 1 here with the recursive pattern, this would be a 1. What would this be? 2. So 1 purple is equivalent in length to 2 red rods. Okay? Does that help you all? Donna, you were gonna say something?
I had to think about what Toby was saying.
Yeah,
He was
okay.
going high level for me. I was like, oh, then he brought it back down to 5th grade. I said,
Well, because when he said 2p,
Yes,
that made me think 2 times the purple equals 4 red.
yes.
So if purple is 1 and red is,
If purple is 1, then red depends on what purple is.
right,
Thank you, because that's exactly where I'm going right now. Okay? So a little bit of teacher talk here, okay? As teachers, we understand the nature of this table. Which one depends on the other in this table? Do the number of red rods depend on the number of purple, or do the number of purple depend on the number of reds? The number of reds in this chart on the number of purple. So that is a function. When you have something that depends on something else, that's a function. So, we call y the dependent variable. X is the independent variable. Okay? Now, fifth grade students are gonna have to be learning that now within their revised text. So it's just gonna be building, and that's not difficult for them to learn. However, here's the problem. I think I've told my people who have been with me for a while, my story about the little special ed boy that I got who just moved in. Okay, special ed, but not so special ed that he couldn't be in my class. It was an inclusion class. And he was, it was an algebra 1 class. And we were doing distance, rate, and time by the time he got there. It was like March or something. Distance, rate, and time. And the formula for distance, rate, and time is distance equals rate times time. So according to that formula, the distance that you drive is dependent on the time that you drive. Well, he argued with me that that was not a function because he said, Miss, when you talk, Miss, we never get into the car and say we've got 3 hours, let's see how far we can go. We always say we've got to go this far, how long will it take us? So in that case, distance didn't depend on the time, time depended on the distance. So then, it took me a long time to figure out what he was talking about for one thing, 5 minutes talking to him, felt like 5 days. But I finally figured it out, and we went up to, got him up to the board, and we rewrote the distance equals rate times time to solve for time, which would be distance divided by rate equals time. Now that's also a function, because time then depends on distance and rate. Okay? So sometimes in some functions, and this confuses kids in high school, one thing can be dependent one time and independent the next. Okay? So you have to be careful, depending on your thought and what your purpose is. Yeah. Okay. But in this problem, that was all teacher talk. Okay. So in this problem, the number of red rods depends upon the number of purple rods. However, if you have a student that says but and goes through this whole long process I just went through with you, have him change the table then, so that then the number of red is here and the number is purple is here, because in mathematics it's a convention, it's not a rule, it's not a law that anybody made, but it's convention that the independent is here and the dependent is here. Just because that's the way mathematicians decided they were going to do it. Okay, it didn't come down like manna. All right? Okay. There are a lot of things in mathematics are that way just because we decide we want them that way, like order of operations. Yes,
Well, and I was gonna say, Dr. Browning, because I had a student, we're actually doing this in class right now, and I had a student say on, I think it was Thursday, said, well, Ms. Capano, every time I see total, I know it's gonna involve multiplication. It's gonna be multiplication, and I said, but be careful, because I could write the rule for that table, I could write it 2 different ways.
Yes.
I could say the number of purple rods multiplied by 2 equals the number of red rods. Or I could say the number of the total number of red rods. So if I said the number of purple rods times 2 equals the total number of red rods. So that would be multiplication. But if I flipped that table and started with the number of red rods, I would say the total number of red rods divided by 2 equals the number of purple rods.
So we're back to the distance, rate, and time.
So I told him, I said, just because you see the word total, your mind should not just think multiplication, because you have to look at what is the process that I'm going through.
And I think that when we teach kids to pay attention to vocabulary like that, that's, exactly what we're doing.
Exactly.
We're teaching them to see total as, a sum or a product.
Keywords, I hate keywords. I go into elementary classes, there's keywords all over
Oh,
the
it
place.
drives me
I'm like,
crazy.
oh. Yeah, because, just as you said, I can write a problem that says total, and it's not a multiplication or addition problem, it's a division or a subtraction problem.
What is the total number of each group? Or
Yes.
each,
Yeah.
Right.
Yeah, the total was 24 cookies, how many did each person get? That's a division problem.
Right.
Okay, so when they see total, when they see 2 numbers, well, okay, let's add, or let's multiply, depending on the grade level. So keywords are dangerous. I mean, they have to understand, they have have to understand the reading.
And I think that's why we have so many misconceptions that we're trying to clear up in fifth grade. And I guarantee, Tim, you've got them in middle school and high school. I mean, they're there. You guys are fighting them like we are because unfortunately, that's what's happened. And we haven't caught them to be able to try to correct them.
Okay, this is just comparing two things.
Yes,
Okay.
thank you, that's where we're going to.
Okay. Whereas a lot of times, or many times in our grade level, we don't just compare two times. We're looking at three, I want to say variables.
We'll get there. We'll get there today.
Okay.
We'll get there today. But that is distance, rate, and time, that's free.
Maybe that's why I'm having kind of a hard time with it.
Get down to the fifth grade, okay?
Yeah.
Come to the, Toby, come to the dark side.
Okay, so let's answer these questions. Are the measurements in the red rod proportional to the measurements in the purple rod?
Yes.
Important word, proportional. What does that mean? If it's proportional. Did you hear him? He said for every one of the purple, there are two of the red. So if you have 2 purples, you're not gonna have 8 reds. You're not gonna have 3 reds. You're gonna have 4. Okay, it's that multiplication, that multiplicative relationship there that makes it proportional. Now, I'm not real sure how much teacher talk I got in there, which I shouldn't have. but-
Multiplicative.
Yeah, multiplicative, that's a word you need to use.
I've never heard that.
Multiplicative?
Yeah.
Oh, yeah.
That's a good one.
Multiplicative, it's fun to say it. Multiplicative.
And some problems are multiplicative or something like that.
Multiplicative.
Oh, my goodness.
It's an adjective. Okay, so what represents the constant of proportionality between the red rods and the number of purple rods? Constant of proportionality, what does that mean?
It's gonna happen every time.
Does it happen every time if it's constant?
Change is always.
Change is always the same. Jean, you want to say something?
Well, I was gonna say what they said, that it's a constant change of one variable to get to the other.
Constant change of one
X
variable.
value to get to a Y value, or a Y value to get to an X value.
And Tim, you were gonna say? About the same. So what is the constant of proportionality? Looking at your table, what's the constant of proportionality?
As the purple rods go up by 1, the red rod will go up by 2.
By 2. So what is that constant that's always there? Look at the table. Yeah. So 2. 2 is called the constant of proportionality. 2 is called, sometimes it's also called the scale factor, if you want to call it scale factor. Yeah.
Can you repeat that again?
2 is called the constant of proportionality, also called the scale factor. This particular unit that I'm doing called. It is a scale factor. We scaled by 2. You know, if you use the scale model, it's by 2. We
What if they
doubled.
use the term double? Is that all right?
That's fine, but you want to get these other words in there too. You would say something like, when you say double, that's the same thing as saying,
Scale factor 2.
scale factor of 2. But now, you people in middle school, what is that constant of proportionality leading us to? Look at your equation, what is it leading us to? The slope. It's gonna be the slope of the line. Okay? Slope. So we call slope a constant rate of change in a linear equation. It has to be linear, it can't be parabola, hyperbola, all those other things, okay? So it's leading us to the slope. So starting in 4th, 5th grade, they have this. By the time they get to this algebra class, that's supposed to be so confusing because of all these letters, they're gonna understand this more fully. In fact, they probably can skip the first 3 chapters in the book and go on. You tell me,
So does a ratio fit in here anywhere?
does it?
That's my question. I
That's
don't
my
know.
question. What do you think?
I was thinking about that too, ratio.
Does it fit? Lisa used the word a while ago.
A ratio has a constant rate of change. I mean, what you, if you have a certain number of one group, then you don't have a ratio unless it's always a consistent rate of change.
Well, if you can say for every one, it goes up by 2, then there should be a ratio. I mean, that's
Okay.
it.
So what is the ratio of purple rods to red rods?
1 to 2.
1 to 2.
1 to 2.
1 to 2.
One purple rod per 2 red rods. That is a ratio. Thank y'all. Y'all are making my job really easy to do. Okay? Really easy. So what's the ratio of red rods to purple rods? 2 to 1. 2 to 1. 2 to 1. 1 to 2, 2 to 1. Okay? Good job. All right, last question. In this description, we've already talked about this. We're so smart. Okay, so they need activity 1 now, ladies. With a partner, you're going to graph the data. She's going to give you some graph paper, the inch graph paper.
Yeah.
On graph paper, write a mathematical sentence, describe it in words, and then share your process for graphing. Okay, you're graphing the table that you have right now. You're graphing that table. Each person needs to do their own graph, but then also discuss.
It's not 2 feet per block. It's half a feet. Well, you say 1 feet. So you would say 2 purple and 1 red. So you're saying, oh, wait a minute, so 2 times, now hold on. Because 2 times the number of purple equals a red. Yeah, and we're walking back. Because that's not, because that's. So I just took the ratio. Yeah. So on that. So each one is 2 then? Purple. Is to, no, it's 1 to E. Because she's like, no, it's okay, it's okay. So yeah, we'll do it with 2. Well, there was some.
And you notice the graph paper has no scale on it, so you're going to have to determine the scale.
So this way,
Yeah, with the X, we just need to ask a question.
yeah, well, X is which way? Okay, so why would you say?
Oh, it's gonna be this.
Vertical and Y is horizontal.
Always? Does it matter? Is there a difference between vertical and horizontal representation on the graph?
I guess, I don't know.
Just.
I guess it just depends on how you arrange it.
Okay, I'm gonna tell you.
That's what I'm saying.
I'm gonna put X as the horizontal value and the Y as the vertical value. So go ahead and graph this way, and I'll graph it this way, and then we'll compare it and see. So we come up with pretty much the same thing.
Yes.
So the X always goes across.
Yes, yes. Yes, there were 2 colors.
So the first one is 2.
Well, it doesn't matter really.
And then
But I really do want to see. Do you mind graphing? No, I'm really am curious. Oh, I totally get it. I totally get it. I'm really concerned about what's changing now.
I was just trying to figure out how I was gonna do this. Straight lines.
Sharpen up one.
So we're graphing these values. So if this is your.
You can't train it in half. And train it in third and train it in
It is not a
Just depending on where you're going to put, you know, are you going to. Yeah.
So which axis is conventionally the Y? We usually put as the Y. The vertical? So which one is the
That has to teach, so.
No, we're gonna try it.
Just trying to.
She said she wants to see it.
Because I understand.
Y axis.
Two.
Okay, so then what you're saying is that each line would be valued.
One, two.
So where we on the line.
1, 2, or 3 more minutes. 3, gotcha.
Over my head. Hopefully you're not expected to stop this out.
Okay, so if this is 2, this is 4, then you're pointing here.
So you have to go, oh, okay. So you don't put a dot here.
I mean, I would just label these lines with the value that I want.
So like this would be 1, 2, like that.
So on mine, I would, well, basically, I mean, the 2 is a number that you can count. So I would just, I'd have to go all the way to this one.
What? Here's a really good idea. Celebration is for every 4, or for every 1.
That might be one of the
That's where the problem comes in. So, but the line is.
But where your slopes are being the same way.
I'm assuming it's all of that. Same line.
No,
So look, if we did this in 1, that would be 2. That's still establishing the line.
No, honey, what I'm saying.
I got stuck in fourth grade, and I didn't want to do elementary as
Is that the same?
really, you know, I had to do math.
What's that about 3 minutes?
And now,
It's going.
How could you describe this language? Not understood. So if I asked you up and over, how would you describe it? Your system. Yours. So every time.
Every time the,
Up.
every time there was a purple, every 2.
Was this an accident? Or did you mix up?
Oh, no, 3.
So out of 3 purple rods, you have 6 red. So really then, you're going up. Okay, so yours is yours up to, or actually yours would be over 2. Is that the same as up to, over?
Is this arranged different?
So then.
But his is, it's the same slope, but his is like a slope of a cablegram because it all revolves to grade. You know what I mean?
You can lay that on top of it, right?
But they establish the same
Is that basically what
Okay.
you're doing?
let's talk about our graphs, and again, I don't have,
Just that mine's more.
the Elmo help.
Yours is like mine.
So- Okay. Brenna, can't remember that. Brenna, tell me one ordered pair that is on your graph.
Alright, 2, 4.
2, 4.
4, 1.
That's what I thank you. I was gonna say, okay, now what does that mean? 2 what?
2x.
2x,
4y.
4y. So starting from the origin, where did you go?
You do the run, which would be over 2 and then up 4.
Okay, over right or left?
Sorry, right 2, up 4.
right to upward. Does everybody have that point on your graph?
Yes.
Good.
Yes.
Good. That's all I need to know, because does your graph appear to be in a line?
Yes, it does.
Yes.
Yes, it does. Good. So I'm pretty sure all of your other coordinates are correct. So let's talk about that ordered pair 2, 4. Okay, it's an ordered pair. Why is it called an ordered pair?
Because first we use our x-axis to the right, and then we go up on our right.
Okay, the order makes a difference. X is first, Y is second. Okay, independent is first, dependent is second. So it's an ordered pair. Independent is first, dependent is second. X determines Y value. Okay? So on your graphs that appear to be linear or in a line, did you connect the dots or not?
Yes, ma'am.
Why would you connect the dots and why would you not connect the dots? Mike?
You're trying to determine the slope.
Okay, if we were going to try to determine the slope, we would need the whole function, which would include fractions and decimals. Okay? But if we're not going to do that, would we connect the dots or not?
No,
Why not?
because our data is discrete.
Good.
Yeah,
And that's the argument that we were having. You can't have a half a train.
The discussion.
It was-
The data is discrete.
not allowed to have a train.
The data is discrete. You can't have half a train, half a purple rod, half a person, even though I sometimes thought I did, that kind of thing, okay? Data is discrete.
So when you say discrete, is that what you're saying, you can't have half of something, is that what you're saying?
Yes, that's what that means. So the dots really should not be connected according to the data that we graphed. However, when you're talking about the function, then you would go in and connect the dots because you want to talk about the whole function, okay? But right now, we're just talking about discrete data. What do we call it when it's not discrete data and we do connect it?
Continuous.
Continuous data. Continuous data. That's a big deal in calculus. Continuous data.
And Dr. Browning, isn't that like the continuous data, that's where you can take any point on that line and you can find your x and find your y?
Absolutely.
So if you're like, and I think about like in science, if I'm graphing temperature, I can tell a temperature for any, this second of the day, I know what temperature it is, this minute, or the growth
Those are
of a plant.
continuous. Time is continuous, temperature is continuous.
Growth
It
of
will
a
be
plant
broken
is
down.
continuous.
Yes,
Okay,
yes.
because that's always confusing in my
So
mind.
thank you, Donna. Have you read my notes? Because that is really one of my questions that's coming
No, I
up.
have not, but my brain is thinking that way today.
Does your graph contain the origin, the 0, 0?
No.
Should it?
It should, it could.
But wait, if you have no purple rods,
Then you would have no red rods.
so
So that would be 0, 0, the ordered pair 0, 0? So
Yeah.
can it go through the origin?
Yes,
Yes, that's a valid point for this graph.
yes.
Okay.
wait, or can it go through?
It wasn't on our table,
Can it
but we
touch
put
the
it.
origin?
Can it touch the origin, because it couldn't go through, because you couldn't have a -1 purple rod.
Thank you.
Right.
Couldn't have negatives here. We're talking real world situations here where there's negatives. Have y'all ever seen any negative numbers in the physical world?
Our
In
bank
temperature.
account.
Bank account is imaginary. Those numbers are imaginary.
Not in the bank.
Temperature, for example.
Is going through the origin sloppy language?
I don't think so because I said it.
And Dr. Browning never uses sloppy language.
Thank you. Is the origin a point that is valid for that equation?
Yes.
Yes, much better, thank you. Okay, and Jen has already told us what the origin represents in this situation. 0 purple rods means 0 red rods. So here's the question, how can you use the graph to answer questions B and C on the paper that you didn't get? Or did you get it?
No, because we have an A and a B.
It's the paper that's sitting right here. It's this paper.
Well, that one has an A and a B, Dr. Browning, it doesn't have a C.
Oh, okay, then we'll skip that.
Okay.
Because I don't have the Elmo. So, is this where I was?
Yes, ma'am.
Yes.
Does the order, do the order pairs have a size relationship? Yes.
Okay. So, we're right here, this bullet right here. Do the ordered pairs in your table satisfy the relationship y equals 2x, your equation? Yes. Every ordered pair in your table? Yes. Yes? If you can find one that doesn't, tell me. Okay. So, do the coordinates of every ordered pair in the graph satisfy that equation? Every single one? If you can find one that doesn't, let me know. They do? Okay, they should. This is teacher talk. This should illustrate the relationship between the table, the equation, and the graph. Those multiple representations, the table, the equation, and the graph. Because the kids sometimes don't see those things as fitting together. And they do fit together. And the kids have to be able to go from one to the other fluently, without having to try to think. Okay? Yes, ma'am?
I have a quick question, I'm sorry if you covered it. Did the bottom left-hand corner, does that have to be 0, 0?
No.
Because it could just be like a close-up of the graph. Like, I was just looking at what Eugene did, and he chose to make that point 2, 4.
Yes.
And that would be okay?
That would be okay, not right now in the 5th grade. But later, yes. Because I gave you a blank grid. You could put the origin anywhere you wanted, or you could start with 2 down there on the y so that you would have more y values that would fit on the graph. So no, it does not have to be.
I guess what grade level is that okay? What, 7th grade, is that okay?
Yeah, 7th grade, 8th grade, high school.
Okay.
And usually they're using the graphing calculators and they click the window.
Yes.
Yeah.
That's how I saw it, but then I was not sure how.
Okay, because I'm like, no, in my 5th grade classroom, that's 0, 0.
Yeah.
Here, 0, 0.
Okay. We're talking more, never mind.
That's the first coordinate quadrant, thank you. for
Yes,
clarifying.
yes, 5th grade only does first quadrant.
Yes, that's the first quadrant.
I did get the notice though, Sherry told me, when we were at Divine the other day, that 6th graders will now be allowed to use, is 6th grade or 7th grade? 8th graders, thank you, will now be allowed to use, graphing calculator on STAR.
Oh, awesome.
Starting next year.
8th grade, starting into 2015. So that means that the 8th grade teachers have to get them out and get the kids familiar with them so that they don't waste all of their testing time playing with their calculator and saying, oh look, I can even text on my calculator, which they can, but they need to know that beforehand so that they won't be wasting time.
Did I read it correctly that next year the STAR is going to be covering the same, it's not changing next year?
It's not going to the revised?
Yeah, it's not gonna test the revised.
I have not heard that. I don't know. I'm not gonna say one way or the other because I have not heard that. Okay. All right, so I'm gonna put you in groups now. I want you in groups of 3. Y'all are 3. One of you needs to leave. Not the room. Y'all are 3. These are 3. Okay? And I'll have one group of 2.
Lisa.
One, okay, then I'll have Jen. And then 4. Okay, you stay there. So here's a group, here's a group, here's a group, here's a group.
Oh, 3.
And Lisa is moving in the back here. Okay, listen to me carefully. We're not in time, in the effort of saving time, we're not gonna do every single problem. So some of the groups are gonna be doing activity 2. Some of the groups will be doing activity 3. Okay? Some will be doing activity 2, some will be doing activity 3.
One more.
Then we'll come together and discuss those. So I want this group to do 3. Y'all can do 2. Y'all can do 3. And y'all can do 2.
We're doing, y'all are doing 3, we're doing 2.
Yeah, 3, 2, 2.
It says activity.
Yeah, I'm passing out 3 also.
Oh, okay. So what we
Just said 2.
Now we're 2 or we're 3?
3, 2, 2, 3. The 2 front tables are 3, the 2 back tables are 2.
So here's a blue rod.
Okay.
But this is the first thing y'all do. All y'all need first is what's up here. All y'all need first is what's up here.
Okay, that's fine. Okay.
Was that a question or a statement?
Is our relationship?
What is our relationship?
What is our relationship?
Yeah. Wherever you got one, you got it.
And we're gonna do it, what is it called?
Don't do this yet. Just do what's up there. I'm gonna go back to I'm gonna go ahead to the next slide, because some bricks are ready, and then I'll go back to this, okay? Once you have this figured out, you're going to get some chart paper, or maybe the girls would distribute the chart paper. You're going to create a table, write a mathematical sentence, an equation, write a equation in words, and the words will not be y equals something, 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 okay? It's gonna be the back, whatever the cubes, the rods are. Graph the data on the chart paper, and then describe your graph in words on the chart paper. So you're gonna come get a piece of chart paper, or I'll bring it to you. Make a 4-quadrant fold, which means folded hamburger, folded hot dog, so that you have 4 pieces, okay? Create a table in one of the pieces, write those sentences in one, graph in the other, okay? Y'all got how this goes?
Yeah.
All right, good. So, do I need to go back up to the other screen? All right.
What is it? I would say the registration.
Kimberly, this is ours, right?
I believe it is.
Yeah, that is ours.
Okay.
The way I would write it on my fifth graders, that was what I Well, we're discussing it.
Where are the markers? Oh, I want to know about these.
Okay, because
You need markers and sticky notes.
multiply
Marcus is 50.
by
Here's more.
3 equals.
Okay, so.
Jen Ready wants to put their Post-it, so it's gonna stick.
Just stick it on the end of the Yeah.
We have to write the mathematical expression and then we have to do a synthesis. So just like this one.
Well, so if this one is just
It's like a keep it together, right? Thank you, much easier. Everyone else, please? No, I mean, it's just where it sits.
It was open.
I was thinking like that.
All right. I knew when they
Well, I mean, and then I heard from them, that their alternative
Yeah, he was next to me. Yeah, they always have wrong sometimes.
Oh,
Has she ever asked that question? Has she not been in this situation?
This is the one purple lot, not one time. So this really
Please don't.
we're not saying that one time.
And I'm ready to go here.
Okay, normally we don't have a lake
Sorry, I just need a Chevron.
First one?
Chevron yelling at me because I wasn't answering her.
Oh, no, I have no problem with that. I do Dr. Wicks, you said his.
Hi, Donna.
Oh, yeah.
I was telling you I didn't see the text. I had my phone put up.
I forgive you.
I don't really have an extra, and I go buy one. No big deal. They told me to tell you that.
I know because,
Smarter, not harder. Yeah, you know. Can we work smarter, not harder?
For every
Maybe the girls are work or something, they bring things.
Yeah, they were in a ride.
I know, I was waiting, I was like,
So let me take
That's the relationship and the numbers.
so what, and then it was gonna be.
I bet you there's some.
Yeah, this one is there.
I see some blue bottles coming
I believe so, I think, Tanya,
That's in the
Tanya.
road, you're saying
that, so do you want people to
That for one,
So how could you change this?
So X would be what?
Oh, it's so nice to see someone know how to glue things instead of like order.
I don't know if the verbiage is correct.
I follow them within grade, where I'm like, please stop.
So three, X.
Right,
So not this one,
The variable would be one.
you can actually. Yeah,
This is X. And the pattern would be by one.
Yeah.
Three of those is
No, one of these equals three.
So with your 3x equals
So
y.
X times three.
How many?
She changed the thing. so-
Green rods.
Oh, she- oh, sorry.
So,
No, but move on, cause I'm.
No, no, but we gotta make sure we get it.
And the- we have one.
We have one blue.
That's the mathematical field.
Yeah, I mean, that's what
How
I
many?
think. Or we could do 3 times x.
And then when you have it together, it's
Because you
one.
know, the parentheses is
We could do both and show the. I don't know, oh, okay. So we have to put both the words.
in this part right
I
here.
don't understand how you.
So A, to A,
So we gotta do the
mathematically,
equation.
mathematically.
The form.
I mean, you could do X times three. The reason I is just out.
And I don't write well, so I'm like, I'll let it go with that.
Not the variable, we like to do because that is the
Convention.
That makes sense?
But if you're reading it backwards,
It doesn't matter.
you can say X.
Alright,
And then you can notice. Yeah.
Which is why we don't do the
yeah.
So it's the same.
Yeah.
Yeah.
So if you're calling this your X, in order to find Y, you got to multiply your X times 3, and it's exactly what you did. You're saying X times 3.
Then it is perfectly acceptable. My sevens have a cross through.
Is
And then
three units.
No, the Y is going to be your results. For every, yeah, so for one of these, right, so one of these.
Three of these, yeah.
So two of these will equal what?
Okay, I got it.
So what will two of these equal? Of those?
And in Spanish it would be cositas.
No, yeah, nine. No, six. Okay, six.
Well, you can do the
I'm not
X.
counting the little pieces. See, that's what he wanted to know the units.
Right.
The process of the bottom?
No, count as the
That's why I'm confused.
So I'm 3x and 1, 2, 3 times X equals Y. So this means for every
Dr. Browning, he got it.
every
You know, we spent, after I got back in, everybody was like, and he's sitting there and his windows are going back. Google just so much and said, "Go to the tiles again." And so he started working on it. It took another 10 minutes, but he finally got it. And then when he was, how do I get it? So he would reach,
good for you guys, every one of these rocks.
So every group of purple, so every group of purple
The length of three football rods equals the length of four latrines. That makes you all done. I got you.
Have you seen other parts of the
That was too
Yours are making a stink.
I don't know. No. You tell me. Yeah, that's the first time. Oh my God. I'm gonna die. That's horrible.
Dr. Brown,
Let's fix it.
Title describe what
What's fair is not always the same. This is
It's a Hispanic
younger cat is fluffy. So yeah, I had a kid. He looked just like that. Really? Oh my God. It was, and he corrected me. She wants to go do some, she wants to go borrow a free go.
One, two, or three more minutes.
5. You're a seasoned professional.
No, well,
It's so good. No, it's in Clunky. It's out there by Clunky. Yeah. I have to take like 4 days. They don't take care of it. And you can go to Lost Lake Road. It's really good hiking trail.
Just two
I grew up It is weird, yes. But that's because it's clean. It gets warmer as it gets crisp. Because when they put the can down and you rock right here, it starts my water starting to cool off as they go through because that's what you can talk about.
so it allows.
I bet we should do that.
I can't have that be that way.
It kind of gives them the opportunity to go out and
One, two,
We
three,
have to go up there with it.
when I don't make a mistake.
Oh, yeah, I guess some of the shit stands out like
Oh, because this was number 4 on their services. No, I think number 2.
you have to have a constant.
Graded techniques, they're gonna write us somewhere.
So
Chronology describes, our mathematical equation is y equals 3x.
I got it, just bring that glue back.
Okay.
Does she want to? And then we're going to describe and now we will describe the graph. That was our last thing.
So if y, or if x is the length of y,
That's a fun stuff.
That's what we said.
Where's the section, the hard?
No, we're using this.
This group didn't have the table.
Believe the one blue bar.
Equal to one, or three of the library.
This is considered wide.
Correct.
So the leave the one.
2-minute warning.
Yeah, El Paso, you know, we talked about today, for every
And that's why it's
drive.
three, because you get units versus one.
Or even worse,
Right,
sometimes
every
like
one,
normal digits.
there are no. Is that 3 flatbeds?
This is two sets.
For the length of,
Or it's the lane.
This would work.
maybe down Those are and this is kind of sounds like that. So that's a caboose, that's a flatbed.
No, she's awesome.
It wasn't one of your.
Like it's not because it's not in there, I just always put it. It could be, it would start out at 0. There's no.
See, because they're saying
Lead rods
a
then.
flatbed, right, so, why, they said this is equivalent, how would you?
Wait, say it again?
So if you were doing a ratio, the blue rod is X, there's no exact
Blue rod, and there's 3 like that.
and that's a caboose.
Which is.
And that's
Three of three of the lines.
right?
Blue, let's call it blue this
For
one.
every minus the
Maybe try
last bit, so do 0. That's what it is. Here's the 10 right here.
Or we can just take it off.
Because it's a ratio, it's a flatbed, because it's a flatbed. For every
Oh,
Yeah, so this ratio is.
it may be fine.
She says, all right, this is 0 to 0. Right, yeah.
Don't do that. I'm sorry, I don't like it. Yeah, that is what I understand, that's just like the previous one. Well, I mean, that would be my understanding, because if you look,
Well,
Yeah, because it says this is flatbed,
so then
so
minus 9,
3 blue rods, and
right,
length.
minus 3, as you minus 1, so it'd be 0 and 0. That's what I'm gonna say. Make it sound good, alright,
So a
good.
flatbed, this is a flatbed.
You're like, I was just guiding.
It says to describe.
No,
The fourth thing was describe?
No, Dr. Rowdy, can you go back to that as well, because here's what it describes the relationship.
Describe the graph.
Yeah, we do need to take.
Graph the data and describe the graph.
Because we are bringing such a, look, here's a caboose,
Did we do yours?
it's on my team list.
Maybe, okay, sorry, independent variables equal ESG,
I think that is the.
and then our dependent variables, that would be like green rights. So X or dependent independent variables.
They didn't do that. There's a caboose, and then there's a breakdown. Are you kidding me? The same.
Yeah, so you're going to move right at 'Cause as we move.
So it's still that one.
Yes, ma'am.
Yeah. That's what
On this, do you want us to talk about whether it's
It'll still show the.
flatbed. So a flatbed, when you find a flatbed.
Olympics?
Let's do every other one.
Yeah.
So
I know.
I don't like the new job. 10.0.
What color you want?
I just like watching my, do you care what color you use?
Everything's color coordinated in our house.
I'm sorry for bringing up.
I think
Actually, I won't.
Blue rods and zero.
It is, one by one.
Cross.
Well, I mean,
Cross
go,
the order.
Because it's the same
you would
relationship.
always have.
You always still could. It's possible to have no blue rods and therefore.
Follow that rule, follow that.
Then you'll feel like a hospital, I guess.
Well, yeah.
Unless it takes 3 blue to make complaints in it. So it takes 3.
You always have two things. Wouldn't just be time by itself.
Wait.
I think our brains are just trying to process, or trying to
You
think of
could have
blue.
no time.
Where you would not.
Is that exactly right? Is that what you
So if we make green,
Would not have.
Watch her.
I see what you're saying. So let's not call it adding one. I know, let's call it adding. The rule has to be the same. That's what I'm saying. So when I add the green,
and then you say, for every,
add the
for
difference.
every one
This rule's not gonna
So why do you make it? The first half of the rule was this line.
Go ahead.
Is there? I would say.
That you could say,
Cover all the
doesn't start, or any thing that doesn't have a start at order. She said time and then decided. Maybe time would be good. What would you say? Like, is there anything you can start off with nothing of? I mean, yes, like a hero.
As we move right, every
So everything starts at zero.
unit we move to the right of the graph.
one teammate.
Yes.
To the right.
Synergy and alignment.
We'll move up. So it is a linear graph.
That's right, synergizing, putting first
We
things
know it's a
first.
linear graph because as we move
Wasn't that hard
to the
after?
right, x-axis, we move up the
She sees, I
Okay, that's how forward that goes.
yeah, we will.
I didn't take it this time. Look, yours is.
I said it the other day, we feel it was like, oh my God, what's that fluffy? A linear graph, we can see that this is a linear graph.
From the origin on the x you must move up 3 on the y-axis.
The constant rate of change. The rate of change is constant.
Okay, 1 minute, we're gonna post the graph, and then your group is responsible for explaining it to the rest of the class. Now, in this classroom, I have no idea where we're gonna post those. So try to find a place where you won't be pulling people, paper off when you remove it. The door would work over there, yeah, but you can't. 1 minute.
As we move, okay, so as we move on the x-axis right, 1.
I mean, we can label it.
To the right.
Explicit rule, everybody else has responsibility. Well, and we can for the Y value.
Perfect.
What we described.
Well,
Up the y-axis.
Should have wrote it out, I decided to commit it to,
And then maybe this is shown
Good
as
point,
the
Ralph.
order
He's not the order now.
Okay, so I'm gonna
So we
cross
see-
off out of the origin.
White out.
The function would be.
Let's start writing.
Well, let's just write that one too. Okay, you write a lot better than I do, so I'm gonna let you
It just
write.
shows our thought process.
Yeah.
Slow down.
Okay, let's get them posted somewhere.
Put on your tape. Oh, I'm already not digging this.
Okay, where are we trying, where are we supposed to go right now? Here, y'all make a vote. Please don't let me turn We find a spot to sit? Yeah, good. All right. Oh, I see it. Ooh, looks good.
I mathematically.
There you go. I think you could even put one on the whiteboard over there. He's got a really.
We call that spot.
whiteboard.
Over the last ones.
No?
Then we called it.
Seems very skinny. That wood wall seems very skinny.
This is the closest to you.
This is all.
I don't know. It was just,
Was that already?
yes, you gave it to me.
Yeah.
It's Jen's, Jen? Oh, it is. There's nothing.
Not of his, I have one just like it,
Oh.
but mine has.
My daughter has one in the room, but it's different colors, it's like purple.
Yes,
blue,
it's
red.
mine, it's in my classroom, but he uses the expensive one.
Oh, yeah.
Yeah, that's expensive.
It's a different light.
Now you
See, that's not for the.
They do, these do last for,
Well, you're gonna tell me. Dispose of them in the trash can. I don't know what you're supposed to do with them.
no, that is not true.
They haven't.
Okay, we're gonna start going over these. Y'all ready?
Yes.
Okay, Craig is there. All right, we're going to start with Tanya's group. And this is what you're going to do. You're going to explain each part of your group. Keep in mind that they probably can't see the table over there.
Okay,
So we are going to assume that you're correct.
okay,
Okay, but read a few of the ordered pairs.
okay.
Now, let's give her our full attention.
All right.
Way to go.
Come on, lady. Okay, so on our table, we just saved time and put the table that we used on the activity. And we've got,
Let me put that back up here. They had activity 2, so this is what they're doing. Okay?
I
Did y'all have two also? I'm glad I didn't
We
take what
did.
y'all had written.
We did.
Okay. I went and checked theirs to make sure mine was right. I didn't like it, so I came back over.
Hey now.
Not that I didn't understand it.
Thank
but- Okay, so for every blue rod, we went we increased by 1 on the left-hand side, and then for every on the right-hand side, we've got the light green rods, and they increased by 3.
So for every independent variable, it increased by 1
Uh-huh.
recursively,
Yes.
and the dependent variables increased by 3 recursively.
Yes. Okay. And then we've got, we did our written description was 3x equals y.
Okay.
And then our written description was as x increases by 1, then y increases by 3.
Nicely done.
And so then Brenda did the graph.
Yes, so on the y-axis, we had to do by 2s so that we could get all the points graphed. And
Oh,
then,
wait a minute, what is the y-axis?
sorry, the y-axis would be our dependent variable, which is the light green rods.
Okay.
So we did it by 2s because we needed to make sure all of it would fit. On the x-axis, which is our independent variable, or the blue rods, we did it by 1.
You increased by 1?
Yes.
Okay.
And so then we just plotted our ordered pairs, which one of them would be 1, x is 1, and then y is 3, and all the way up.
Okay, so it formed a, what shape?
A straight line.
It's a line?
It's,
Okay.
and we said over here that it's a linear graph because the rate of change is constant. And as we move on the x-axis to the right, to the right, we move up the y-axis by 3.
So every time you move to the right 1, you move up 3?
Yes.
Very good. Okay, so their graph is a line, and is 0, 0, the origin, is it a valid point for that situation?
Yes.
It is. So if you have 0 blue rods, you also have 0 green rods?
Yes.
Okay. Okay, so answer this last question. If a flat deck tire measures 3 blue rods in length, how many light green rods long is it?
Okay, it would be 9 light green rods.
Because?
Because we increase, or we multiply by 3 for every blue is times 3 to get our light green.
Okay, then multiply the blue times 3 to get green. So what is your constant of proportionality? What is your equation? Your
Our
mathematical
equation would be the 3x equals y.
3x equals y. Could I say y equals 3x? Okay, because usually in algebra, the y is,
The left.
that's just convention, there's no absolutely reason. So y equals 3x. What is your constant of proportionality?
1 to 3.
That's your ratio. Very good. That is your ratio. 1 what?
1 blue rod to 3 light green rods.
Sure?
Yes. Correct?
Yes. 1 blue
To 3 green.
Green. Okay. So what is your constant of proportionality from your equation?
3?
3. 3 is your constant of proportionality or in scale factor. Got it? Okay. Good job, ladies. The other group students. Come on, Craig. Do it. Hey, do you need me or Dr. Wood?
Do you want us up there with you? Or can we cheer from the side?
Greg is going to explain theirs.
I'm gonna cheer from the side. Slowly. All right, Craig.
Yes.
You sure do. We'll just talk like we're all 10 years old. Because we don't know.
So, in our first quadrant, we have our table. We have the number of blue rods, the process, and the number of light green rods. For every 1 blue rod, you have 3 light green rods.
Good job.
Okay. We also labeled it one flatbeds and cabooses. So for every one flatbed, there are 3 cabooses.
So you're telling me that a flatbed is the same length as 3 cabooses?
Yes.
Yes, okay.
In our table, you can see our constant of proportionality in the process column. Because for every blue rod, you multiply by 3. So I have 1 blue rod times 3, 2 blue rods times 3, 3 blue rods times 3. So I'm always multiplying by 3. So that's my constant of proportionality.
Okay.
Okay. The equation in the table is 3x equals y.
Good.
Okay. So our written description, the number of blue rods multiplied by 3 equals the number of light green rods. So blue rods times 3 equals the light green rods. Okay. In our graph, in quadrant 2, we have
Quadrant 1.
oh, 1. I guess it's 1, 2, 3, 4.
That's
All right,
okay.
there we go. In this quadrant, our graph goes. We labeled our y-axis. Oh, number of light green rods.
Good.
Or cabooses.
Or length of caboose.
Good.
Okay. And then the title of our graph is comparison of cabooses to flatbed cars. And the x-axis is the number of blue rods or length of flatbed. Okay. So it's discrete because the line is not connected. Or the points are not connected. Because we do not cut a flatbed car in half or a caboose in half.
Not intentionally, okay.
Okay. We can include the origin, which brings us to our description of the graph. It says the comparison of cabooses to flatbeds creates a linear graph. For every 1 flatbed you will have 3 cabooses. The graph could include the origin because if you have a caboose, you do not.
have 0
If you do not have.
Oh, if you do not have.
You do not have a.
Oh, do not. Okay, see that now. If you do not have a caboose, you will not have a flatbed.
Okay.
So no cabooses means no flatbeds
In this situation.
in this table of graph.
Okay?
Any questions?
I do, I have questions. I like the way they always tied it back to the cabooses and the flatbeds, rather than just the green rods and the whatever other color you had, blue rods, okay? Tying it back to that real world situation so that the kids understand that it's talking about cabooses and flatbeds, not just numbers and rocks. That's one way that you get them out of the use of manipulatives eventually, is to tie it out, constantly bring it out of the, what am I trying to say?
Abstract.
Concrete.
Yes, out of the little tiles that they're using into the real situation that it is illustrated. Okay, Tanya, you got a question?
I do, and this actually brings me to a different thing that I teach whenever I'm teaching conversion. I was fine with everything until I looked up and it said flatbed and caboose, and it says 1 flatbed times 3 equals 3 cabooses.
Equals 1 caboose. One flatbed
Times 3 equals 3.
or the other way around, I'm not really.
Where are you talking about? What section?
Like I was looking up here. You
Right.
got flatbed up here, you got caboose.
Right.
So then I go here, and that tells me 1 flatbed times 3 equals 3.
Equals a caboose.
That says 3 caboose.
No, it's 1 caboose. I can't see the 3 from here, but it should be.
No, it is, that is
Yes,
right,
it's right.
because here's
Which one's
why.
bigger, flatbed or caboose?
So I have, and I'm finished, I'm
Flatbed,
gonna
right?
go back to the
So you
manipulative,
have
because this took us a while.
3
Okay.
cabooses for 1
So,
flatbed.
we said, this is a flatbed.
Would you go up there and stand up in front of your
One
team?
blue is a flatbed. This took, we had to do the same thing, because our brains weren't wrapping around it. This is 1 flatbed.
The blue.
This is a caboose. So, because it told us in the problem,
Flatbed.
No.
Flatbed caboose.
I'm sorry,
The
See, we
caboose
got
is
But that's
confused.
what
one
that
blue.
tells me. That's
No.
what I pictured.
no.
That's
My
what
facilitator.
So hold on, this is a
let's read the
That's
problem.
Caboose.
Mhm.
So this is a caboose,
Hey, hang on,
and
Donna.
this is
Let's
a
read the
flatbed.
problem real quickly. It says, the caboose is a blue rod. Hold that up for us.
Caboose.
One blue rod.
The caboose is one blue rod, thank you, Craig.
See, it took us
It's
a while.
also 3 light green rods, so we,
Oh,
3
I got it.
light green,
the length of one blue rod is the same length as 3.
3 light
Light green
green.
rods.
So down here, you have 3 blue rods. They changed the length of the flatbed here, okay? This flatbed is now bigger. So 3 blue rods for the flatbed, that's what Craig is holding up, is how many light green rods?
Would be nine.
Nine.
3, 3,
So-
3. 9
9.
One flatbed,
is 3 cabooses still.
Right.
no.
No.
Yes.
Yes,
One flatbed.
this is a flatbed,
And that's a
this
caboose.
is a caboose,
But
because
it
it tells us
changed
at the
it.
top,
Because it
the length of the
enlarged.
model caboose is 1 blue rod.
Right, and I,
So
and I
here
see
is
that,
a-
and it's also equal to this.
Yes.
But the question
And then it
she's
enlarged.
asking is how
The
many
ratio is
light
the
green
same.
rods is
Right.
it?
Yes,
So
but
it would be 9.
But when you look at our
Light
the
green.
question
table,
that Tanya was asking was about,
yes,
does one flatbed equal 3 cabooses? And it does, because one flatbed is 3 blue rods. 1 blue rod is 1 caboose. So 3 cabooses equals 1 flatbed.
But
3
I'm saying that,
cabooses
Hang on,
equals 1
Fred.
flatbed.
Hang on, Fred, she had a question.
well, I don't have a question, but but that question, see, we did the same thing, but the question doesn't say, I mean, I know that these are equal, I understand that, that this and these.
The length of the blue
The length of the
equal to-
blue equal the length of one blue, but the question asks how many light green rods?
right, but Tanya's question was, her confusion lied
Hang
in
on,
the
Donna.
fact.
So the answer to Jen's question is, and this question is 9. Everybody agree
Right.
with
Yeah,
that?
and I
Is that
think
in your
that
table?
Yes,
Is
it
where-
is.
That's correct in their table.
For Jen's
It's correct in the
question,
table.
it says 3 rods in length equals how many light green rods? So I have 3 blue rods,
Uh-huh, there it is,
9
it's 9.
light green rods.
Yes.
It's in there.
But you can also answer, we did extras, you can also
Instead
answer
of
1
saying-
flatbed equals 3
One.
cabooses.
Okay,
So-
so Donna?
says one flatbed is 3.
So Tanya was saying, it did make sense in her bed that 1 flatbed would be 3 cabooses, and that's when we pulled out, because we had to do the same thing, we had to really think it through. And so if the 1 blue rod equals a caboose, and a flatbed is 3 blue rods, then how many cabooses, you can see, I can break up that flatbed into 3 individual cabooses.
So I think the question is, looking at the pictures you've drawn above your chart, what is the picture on the X values?
Oh, those aren't
Those are crossed
pictures,
out.
those are, we messed up the word labeling, and so we had to mark it out.
So
So
those are
that's-
nothing up there.
That's nothing, that's a scribble.
Okay.
We should have scribbled in another color so you didn't get confused.
Is something still bugging you?
Yeah, I think it's a,
Yeah, but I
Something's still
can't
they have it
explain
labeled
it.
2 different
I don't-
ways.
Is anything wrong in this table?
Yes.
That's my question.
I would say yes.
Let Kimberly finish. Let Kimberly finish.
My thought is that you, in your table, you've labeled number of green rods, but when you're showing us what a caboose equals, you are showing us the blue rods. But you've also labeled it, so that's what I'm saying, but a caboose, if you're showing the 3, shouldn't you like label? Is that where the confusion
What are you
is? Is
asking?
like where the caboose is represented by, I know it's the same
No,
thing,
I'm asking-
but when you
I'm-
label it, I feel like if it's not labeled clearly the way you're showing it, then that, you're saying that it represents 3 light green rods, but you also said it represented 3 blue rods?
See, I'm not.
How can it
He
represent?
I know what it
say
is.
that. He implied that when he held up the blue. Can
Right.
you hold up some green, Don? One
I
of
have 3
Toby or
greens.
Donna do the green and let him do the blue.
Hold on, I need some more green.
Yeah, you're gonna need some more.
I feel like you're saying it equals 3 blue cabooses, and it also equals 3 light green rods.
And that's not correct.
No,
So-
because it says number of blue rods is 3, number of light green rods is 9.
So hold those up.
So
But when you visualize it, you're showing me 3 blue rods, so I don't know if that's the like, I feel like
It-
that's
it-
where.
It will confuse children, so Donna's fixing that now.
Okay.
well, and what I was gonna say is, it's the proportion that we have, because Craig has, he's got a 1 blue to 3 blue, so hold those. I have a 1 green to 3 green.
Okay.
And so I know that 3 green is the same as 1 blue. And so this proportion of cabooses to flatbeds is the same as, I just scaled it down, this proportion, this 1 green rod to these 3 green rods, or 1 blue.
Okay.
So it's a scaled down, it's kind of like when we learned the planets, it's a scaled down model because the ratio is, the proportion is the same. It's still a 1.
What was the ratio?
The ratio is 1 green rod to 3 green rods, which is a blue.
Or
1 green rod to 1 green, 1 blue is 3 green.
good. 1 blue is 3 green. This gives you your ratio.
Right, 1 blue is 3 green.
Okay. And then you switch that to, so that means that 3 blue would be
9 green,
9
3,
green.
6, 9.
Yeah, but you were holding up blues, and that confused people.
That's
So
right.
you have to, now when Donna did the green over the blue, did that clarify for you people? who were
3,
confused? Tanya?
6,
I think
9.
I know what, it's clarified. When we wrote flatbed and caboose, if you cover up number of blue rods and cover up number of green rods, and you put caboose here and flatbed, for the X, the title of the X would be flatbed and the title of the Y would be caboose, then the table would still make sense.
But you would be cutting the
But you
flatbed
can't-
into parts at that point, because the flatbed is 3 blue, so you'd start at 3.
No, you're taking out number of blue rods, and you're just talking about flatbeds.
But
So
it
if you-
says the flatbed's 3 blue, so that's what throws me off.
So think about it, if you have a flatbed, but you're saying that 1 flatbed is the same as 3 cabooses?
The length of 1 flatbed is the length of 3 cabooses.
Down there it says it's 3 blue.
Caboose is 1 blue, it's also 3 green.
It
So the
doesn't say
caboose is
flatbed.
the blue.
Yeah, on the flatbed measures 3 blues. Did we?
I feel like they're not interchangeable. You have to label it one or you have to label it the other, because it doesn't make sense for for 1 rod of blue to also equal 1 flatbed. I think that's where, to me, that's the hardest part to wrap. But when you said to cover it up,
Yeah,
and I
'cause
just
you-
totally ignored that,
Yeah.
and then I transformed into blue rods with you, I'm totally
Yeah.
there.
Yeah.
When you
Put
have
them together or-
both, I can't go back and forth.
That's what's happening with me.
So Jen has a question?
So no, I think another way to say it is, yeah, forget about rods now.
Mhm.
1 flatbed. Wait a second. Is equal to 3 cabooses. Forget about rods.
Yes.
1 flatbed is equal to 3 cabooses.
It's like too much vocabulary, it's like, you're either gonna use rods and sticks to rods, or flatbed and cabooses. And
But I kinda see what you're saying, cause if this is a flatbed, and we're talking about blue rods now,
That's right.
this is 3 blue rods, but what Craig is saying is his table is right. So if you go down to 3 blue rods,
Yeah.
you have 9
Nine
lines.
green.
Would you not start there?
I mean, you could go back to
Because it's like a
this,
flatbed, which
but
is
you
3
have
blue
to,
rods.
you don't start with 1 if you're doing this.
Yes, right.
Okay, the difference, I think, would be, is in your title.
Yes.
If you're going to talk about flatbeds, then you can start at 1, but if you're going to use rods, then start at 3, start with 3. And that would
So,
erase a
if-
lot of the
if-
confusion.
If I was teaching this, then I think I would have them first do that, the first problem, and make the graph. And then I would have them make a second graph that shows this, starting at
Right, I agree.
3, right?
And this graph
The
would be
size of the
subsumed.
flatbed, which is 3.
But would this graph be subsumed into this graph?
Yes,
It
it
would
would
be
be.
every third one.
They
That would be a
could.
good point to bring out.
But I see, cause I got confused too, because we were calling one thing 2 different things. We named it twice. We said, okay, it's this and this. so. Right.
Okay,
But it's that scale model.
Right.
One, the ratio of,
But that's really what we're getting at.
yes.
His
Yeah,
question?
I think, you know, what you're saying is right, but this one cannot be is not a flatbed. You know, they're charged, right, because y'all, we got the same data as y'all do too. But I think the way you're looking at it, this is not one, and that's what she's having.
Tell us why not.
Because it takes 3 cabooses to make one flatbed,
So how much of a flatbed is that?
1/3,
1/3.
right. So we're kind of, you know, if you say one, we see one on the chart, but it's more one blue rod than a
Then a flatbed.
flatbed.
That's why I think
So, yeah, that's I think
First,
what you're saying.
I would build that ratio before I started doing this. Before I started
You would
saying,
start off
okay,
with the
now we're gonna make.
Yeah,
Table
basically, we're
for
starting
this.
off at the 3,
Yeah.
but it's still right, because one blue rod does equal 3, but it's not a flatbed.
But then, after you do the ratio with 1 blue rod to 3 green rods, you could say, okay, so can you tell me if I have a caboose, or if I have a flatbed that's 3 blue rods long, how many cabooses? And then they could use that to do this.
Yes. Those-
So yes,
Those
what you
questions,
said would,
reverse things, reverse all those questions.
well, the first graph could incorporate the second, and from the first graph, they could build the second.
Okay, but the question that we were given,
And not the actual flatbed.
Yes.
then we could start off with 1.
Well, if you're talking about flatbeds and,
And we'd have to get rid of that.
yeah.
Right.
So we were trying to put that real world piece into
Yeah.
it.
It was
And
the
we
labeling
wanted
that
to-
confused the people.
They, like when they said one flatbed, they were thinking, this is a flatbed,
Right.
and it's not a flatbed.
Yeah.
Flatbed's
That
a
why there are a
flatbed.
ton of questions for them, and there weren't a ton of questions for them? It's the same problem.
It's the same good
It's a
question.
it's a matter of
This presentation,
Perception.
kind of got us, it's just a.
the perception, the labeling.
I think that makes it, I think it's, I would say we're trying to start a problem.
Nice, 'cause we got this.
Okay, I have a question, real quick, Craig. Why did you not connect the dots there
Because we can't cut a flatbed in half.
into pieces? Okay, but yet we just said that
Yeah,
one caboose is
Yeah.
1/3 of a flatbed or something like that, right?
Cut into
So
cabooses.
mathematically,
Of length.
mathematically, that would work, but in the real world,
You can't.
we wouldn't do that. Right. So kids need to understand that some things work in the math class that don't work in the real world.
Right.
Okay? And science deals with the real world. So we have to be really careful in math not to make blanket statements that aren't gonna work in science. Really careful. Good job. Drew? We have activity number 3, this table first.
Oh, no, we did 2 as well.
You did 2? Who did 3?
We're the only ones that did 3.
Oh, I thought they did 3, but they did 2. They
I
were
thought it was
supposed to
3,
be.
3, 2, 2.
It doesn't matter, as long as we have a 3.
Okay. I don't know.
Where are you?
Right.
Should we just move it over there?
Wherever you think they can see.
Or I can hold it.
We started off with 3. Okay.
You have to stand up here, Tony.
Okay, I'll,
Come on, Vanna, come on, Vanna.
All right, y'all come in here and be in the back.
I'm sorry?
We knew y'all could handle only being on.
Oh, yeah, okay.
So, I'll just go ahead and read our question. Okay, let's give them our full attention. Let's give them our full attention. You can read it sometime.
okay. The length of a model train station is 6 purple rods. It is also 8 light green rods in length. That's not hard.
So, train station as purple and train station as green. Like,
Okay.
If a water tower measures 3 purple rods in length, how many light green rods long is it?
so, looking at this, from the train station to the water tower, it's half. So,
What's half, Tim?
the purple rod would split into half, will be divided by 2 to equal the length of the water tower.
Okay, so we're talking about two different things. We have a train station that's 6 purple rods
Rods.
and a water tower that's 3
3 purple.
purple rods in length.
So, since we had 8 light green rods equal our train station, we'd also have to split the 8 green rods in half to form our water tower, which is only 4.
Okay. Okay.
You see some puzzle faces.
So is this safe to say that this is like one of those STAR questions that have the extra information that you're not gonna need later?
No?
No, because we're still comparing purple rods to light green rods. It's just, the only thing that changed is the name of the rods, what they stand for in the real world.
Yes.
So if we didn't put train station and water tower, we would just have purple and green,
Okay.
okay?
Okay,
Follow
so,
me. Are you still confused?
I don't see where the train station comes in. Am I?
That was just to give us a starting point
Okay.
to form,
To form the word.
of link, so that we can form a ratio, okay?
Got it.
So, where is that represented? Where is the water tower represented in our table? Our water tower is our first ordered pair,
your
Oh.
first coordinate?
our first coordinates
Yeah.
of 3 purple rods equals 4 light green rods. Okay? All right. So based on that, we're just gonna start building our table using a recursive rule of purple rods. So if we have 3, we're gonna use just the next multiple of 3, which is 6, to build the second coordinate. So we had 6 purple rods to 8 green rods, light green rods.
So for every 3 rods that are
Every 3 purple rods,
rods, there are 4
There
light
are
green rods.
4 light green rods.
Okay.
And we just kept that rule going. That's how we built our table. Now, how we came up with our process is, this is one where I had to really think really hard, and it was like, mathematically, I know it's gonna be a decimal, but I wanted to show it as a fraction,
Thank you. Or a ratio.
or a ratio. So I had to reverse green and red, or light green, purple and light green. So I had to put the purple over the light green. I'm sorry, the light green over the purple. And come up with a ratio of 4 to 3.
Okay.
And when I put that ratio together of 4 light green rods to 3 purple rods, and I multiplied by my purple rods, I can get my total of light green rods.
So what did you multiply by?
I multiplied 4/3, which is my ratio, times the number of purple rods.
Okay.
And it ends up being the number of light green rods.
Okay. So your constant of proportionality
My constant proportionality,
Is the 4/3.
4/3.
4/3.
And my recursive rule would be 4/3 x.
Okay.
My explicit rule is y equals 4/3 x.
Y equals 4/3 x. And y represents the
Y represents the total number of light green rods.
green. Okay. All right. Green to purple.
Green to purple.
And your graph is linear.
Our graph is linear.
Would the origin be a valid point in this situation?
Yes,
Why?
because
No green rods, we have no purple.
Okay, you have no green rods, you have no purple rods, okay? Questions? Activity 3 was the first one where the constant of proportionality was not a whole number. Not a whole
it took me a while to.
That was a hard one.
Yeah. Could you have done it with the 3 to 4 rather than the 4 to 3?
I tried and it did not work.
Would it work?
But it would work if I probably, instead of having, if I use 4 to 3, my variable that would change would have to be the purple.
Yes,
I would
your
have to multiply
dependent,
the purple.
independent would have to switch.
They would have to switch.
Would have to switch, which is where I'm going with this. So if you do it the way they did it, their constant of proportionality was 4/3. If they switch it and the y becomes the x and the x becomes the y, then the constant of proportionality becomes 3/4. So those two are, have a relationship, 4/3 and 3/4. right? What is that relationship? One is the one of the other, I hate that question. Thank you, invert, the multiplicative inverse, or the reciprocal, okay? Which is gonna bring me to this table up here, because y'all had that question, right? Mike?
We have two. Oh, yes, about the origin.
Good job. So now I want this table to explain what they did. Okay? Y'all need to listen to this, this is important, it's very interesting.
Now, they did number 2, right?
They did too,
Okay,
but they did it differently,
okay.
okay? Go
I
ahead.
just wanted to
Can we
get
jump over here?
Yeah.
No, we can stop over here.
We're gonna borrow your chair for a little.
Well, it's basically the same as the other two, and, but we didn't get, you know, we just didn't label that caboose and thing, because, not that we even thought about, but I'm glad we didn't, because we started using, we stuck with the rods,
Okay?
okay? And it was the same thing, for every one blue rod, we used 3 lime, okay? And the same thing as they did.
We noticed they take the actual
Yes.
rods.
Yeah.
Yeah, that was our principle, trying to build some points with that. The chart, we do it a little different. We did not do it
that remark.
by 3s, we just did it by 1 so we could just get the first 4 plotted. And it goes the same thing as they said, when you move 1 over to the right, you move up 3. And at first we put origin, and then we started thinking about it, and it's kind of like, I said, well, from this one to this one, and this one to this one, we're not from the origin anymore. That's only the first one. So we kind of had to back that out.
Okay, I'm not clear what you're saying. This one to this one, what do you mean?
I'm sorry, from this point right
Ordered
here,
pair?
from this ordered pair,
What is that?
1, 3,
1, 3.
okay? If we left the instructions of from the origin, we go over 1 to 3, it does apply to this ordered
So
pair.
the right one and up 3.
Yes, ma'am.
Okay,
But from this ordered pair to this, the next ordered pair, it is not from the origin any longer.
okay.
So if we left it in there, it would seem like that always applies. Because then we'd have to say, from the origin, it would be over 2 and up 6.
Thank you, that's what I want to talk about. If you're starting at the origin and you go right 1 and up 3, that's their first ordered pair. If you go back to the origin and start again, and you go right 2 and up 6, are those equivalent? 1 to 3, 2 to 6. They are equivalent. The next ordered pair would go right 3 up 9. Are those equivalent?
Yes.
Yes, they are equivalent. Or you could go from one point to the next.
And it would
Yes.
still be 1 to 3.
Then it would still be 1 to 3. But the 3 to 9 and the 2 to 6 is equivalent to the 1 to 3. You algebra teachers, why?
Because they're proportional.
What's proportional?
The 2 ratios are proportional.
They are proportional, but I'm talking in algebraic terms now, algebra 1, okay? What are we talking about when we talk about 1 to 3 slope? And the slope is constant in a linear function. It's a constant rate of change. That rate of change stays the same. Now, you could go to any 2 points on that graph and write the, how many right and how many up, and it should be able to simplify to 1 to 3, or 3 to 1 actually would be the slope, because the vertical goes to the top.
And would the y-intercept be 0 at algebra 1 for the students?
Would it?
Well, I mean, with the students at that concept, yes. Okay.
In this situation? Absolutely. Okay, go ahead.
Okay. Basically, that's it, because the other 2 teams did an excellent job, like we did.
All right.
Oh,
Okay.
you're just trying to get out.
Wait, wait, wait.
What else can I say?
They have another point that we're going to make. And then Mike decided to do it differently.
Go,
So
Mike.
tell us what you did.
Well, we had just thought about, if everything, if there was any examples of something that doesn't start at a 0 origin, so, we posed that question to Dr. Browning about, if she could think of something that didn't start at 0, you know, cause like if you didn't have, cause everything we are using here is more or less concrete.
Physical world.
Right, so we posed that question to her, She had a good answer too.
And what was it?
The answer was about a plumber who started his rate of charge at 20, just for showing up. So then your origin would be at 20, not 0.
Not the origin, the y-intercept, where it touches the y-axis would be at 20.
And so then it would not cross through, it wouldn't cross, or it wouldn't reach 0.
Exactly, it would not go through the integer, the origin.
Right.
And then it'd
So-
be just a cost per hour on top of that.
Right, $20 plus the cost per hour, so it would never be, there would never be a 0 point.
But is there anything concrete that
Yes.
you could not start at 0?
Yes.
Okay.
If you were getting an allowance, so let's say that your mother gave you 5 cents a day for doing chores, but in your piggy bank, you already had 7 cents. How much would you have on the whatever day?
So you're saying you start at 7?
So you start with 7 cents in your piggy bank, and every day, so on the first day, your mom gives you a nickel. Well, you have that 7 cents plus that nickel.
So let's put that into terms of Cuisinart rods, color tiles, something. So you had 5 color tiles, or 7 is what you said. You started with 7 color tiles, and then the children would have 5 more per day.
Yes,
So what would be on the graph? What would be on the x-axis?
that would be, okay, let me think about this. I have to talk.
What value? We're talking about money and days.
Days.
Does the money depend on the day, or do the days depend on the money?
The money
The
depends
money depends on the days.
So the days would be X,
Yes,
and the money would be Y.
yes. So the first point on the y would be
7. 7
7,
cents already in the bank.
what you started
Zero
with.
days.
So it would be 0 days would be 7 pennies.
Right.
Or 7 cents.
Right.
So for the formula for a slope, I think is y equals mx plus b, would the plus b be the 7?
Yes,
In that situation.
good point, Tony.
Right, the B
Yes.
is the y-intercept, good.
The slope-intercept form of an equation in algebra is y equals mx plus b. That m is the constant that is the slope. And then the b is the y-intercept where it starts here, okay? So none of ours have a b. All of ours are y equals 2x, y equals 3x. None of ours have a b. So ours are all y equals mx, which in algebra, for some unknown reason, they change it to y equals kx, where k stands for the constant of proportionality, which is really the m. So that's what we do to kids all the time. Y equals mx, y equals kx. Kids are going, okay, we have 2 different things here. They're the same thing. And then that b is the y-intercept, where it would cross. Okay? But Mike also decided to put to switch the ordered pairs around, right?
Yes, on the previous one, we switched it around a little bit.
Kind of like what y'all were talking about, or who was talking about it? Where the, y'all, where the one ratio was 3 to 4, the other was 4 to 3. And Jen had the question when they were working over here, curious as to what happens. What happened?
Well, is this it? This is it, right? So in our problem, the slope, well, in the first problem, because this happened with the first problem, not this problem.
Okay.
So, in the first problem, the slope was, okay, I have to think about this, mx. The slope was 2 over 1,
Okay.
right?
Yes.
Okay, so Mike
I think it's 3 over 1.
put his, the first problem, the very first one.
Oh, okay. 2 over 1. Thank you.
So Mike made his horizontal axis y and his vertical axis x, but it's still 2 over 1. Well, I mean,
1 over 2.
1 over 2, which is the inverse.
We just proved that the
of-
ratio is the same, basically.
The ratio is not, well, it's sort of the same, because 1 over 2 and 2 over 1 are sort of the same ratio because you just switch the units that you're talking about, okay?
But if you did that, and you had it like x and y, here we go, where, that's weird. of one up to the of one.
All she did was rotate it.
Yeah.
Right. All she did was rotate
But
it.
if we're looking at it like this, then it would be up one, over two.
So his line's a little flatter, because it's 1 over 2, up 1 and right 2, whereas the other one is up 2 and right 1, which is not too important to 5th grade right now, but 6, 7, 8, and you're building that algebraic understanding, that's important to realize. Okay? Good job. Okay, let me see where we are.
Michael, can you model that? Using the Cuisinart rod, can you probably model that, Mike?
Oh, certainly.
If you had, this was 1 unit, but how can I create, using a different colored Cuisinart rod, to equal this 1 unit? So I could use the 3, the light green, plus 1. 1 white.
Oh, okay, right.
So 1, and it would be 3 plus 1.
I got you.
And the more you build, it's still gonna be, the ratio will still be, or it would be 3 plus 1 for this, to equal, for the light green to equal 1.
Thank you, Jen. Good job.
And Dr. Bragg,
And then it wouldn't go through the middle.
Yes, ma'am.
The other thing that, because I had to stop and I had to go look at our graph, because we have exactly the same problem, but our graphs don't look the same.
And why not?
Because our scale that we use for the y-axis is different than their scale. So my brain, seeing it from a distance, not being able to see the scale, I was like, wait a minute. And I'm literally, I'm doing this, and I'm like, hold on, our graph.
Well, even y'all's in that one, or is that 3?
Yeah, we didn't go by 3.
No, that's
We
2.
just went by 1.
That's just.
Right, and so, yeah, so it really, I was like, hold on, they don't look the same. And so I had to go to ours and look at our scale, and then it made sense to me.
And that's one reason kids should put their own scale on there. Don't always tell them what the scale is. Well, in the beginning, you've got to tell them. Eventually, if they put their own, and then have this discussion about, is it really the same? Theirs is wrong, because theirs is flatter, ours is right. Well, no, they're really the same. Let's look at the scale. And that also builds to the algebra, where they're having to set that window in that calculator, so that their graph shows up. Because sometimes they'll have some graphs that won't show up if you have the standard 10 by 10, you know, positive 10 to negative 10, positive 10 to negative 10 graph. The function won't show up because it's up here somewhere, okay? So they have to set that window, learn how to set that window, which is calculator skills would be a direct teach, when you're trying to teach them how to set their window and all in 8th grade now, when they're using that calculator, so that they don't waste time at the test time playing with the calculator or being confused about what the calculator does. Good question. Thank you, Donna. The slides that I skipped, we talked about when we were discussing the chart, so I was able to skip those. Y'all did a good job. Sandy, you had a hand up?
I did. I was looking at the solar system here. Is there a problem based on that you might could use ratios with this?
Yes, I would tell you this one's not to scale.
No,
this one's
no,
really
it-
nice.
Right, and that was actually what drew my attention to it. So, this is the 5th grade,
Yes.
right?
5th or 4th?
5th grade.
We just finished doing the
Earth space.
relationship between the Earth, Sun, and the Moon. And so we found the ratio between the Moon and the Earth is about, it's an about kind
The
of thing.
ratio of what?
Diameter.
The diameter of the Moon as compared to the diameter of the Earth. That it is about, for every 1 Earth, it is 4 moons. So the diameter of 1 Earth is the same as the diameter of 4 moons.
So the ratio is
1 to 4.
1 moon
No,
to
I'm
4
sorry.
Earths, 1 Earth to
1
4
Earth
moons.
to 4 moons.
Okay. Or 4 moons to 1 Earth. You
Right.
could say it either way.
Okay,
Now,
so
when I said these weren't to scale, I was talking about the distance
Yeah.
from the
And that's what I
sun.
was talking about.
Yeah.
Oh, okay,
Yeah.
that makes sense.
I'm not talking about the volume of the shapes, because I don't know that. I don't know if they're proportional or not.
Well, and when I look at the diameter of the Earth and the diameter of the Moon, I mean, that's, having just done that lesson with my 5th graders, I'm like,
Yeah, that doesn't fit.
oh, that's right, because that's the misconception that we give the kids.
Wow, the sun is 865,000 miles.
So that brings up the point that Jen mentioned earlier, because we had talked about this, that models have their limits.
Yes.
And the teachers have to know their limits of the
Yes.
models and themselves, and clarify with the kids.
I don't
You have
know.
to clarify.
I mean, yes, you need to be aware of the model's limitations, but I think it's really important that the kids clarify what the limit is.
Yeah, I
mean,
don't
what
care
the
who clarifies,
limitation
but
is.
somebody's
Yeah,
gotta clarify.
You know, so after you did that lesson, take that moon down, take that earth down. Does this model work? Is this model really to scale?
Because this was their misconception. They had the moon and the earth pretty much the same size when they drew it. And the sun was just a tad bigger. Well, we had to go outside to build the sun.
Yeah.
So we physically used our own bodies and we built the sun and we brought out our models of the earth and the moon and the diameters and we said, okay, now and we set them up, we threw them onto the ground and we looked at the three of them in proportion to each other and, the kids, it was a huge aha for them. So that when they were then given these little cards to sort and they saw, diameter for the three, they knew, wait a minute, I can figure out which is which. I don't have to remember those numbers because I remember that the moon, and in this situation, they wouldn't necessarily have
Yeah, just
gotten
looking
to
at
that.
pictures, sometimes pictures are misleading.
Right.
Well, it goes back to the fundamental principles that we've talked about before from AAAS. Concrete to abstract, known to the unknown,
Right.
one concept per lesson. And if you stick to those fundamentals, you're more likely to have students learn what they need to know. That's both in math and science. But the other issue in here is what I call good ideas gone bad. This is a nice idea, but it is not scientifically correct in a lot of ways, all right? So is it better to have this in here or not if it's scientifically incorrect? That's a decision that the teacher has to make. I would say no, but, personally. Because it perpetuates misconception.
Yeah.
Right.
Another idea gone bad, as we said, was, some of you didn't get here earlier, but is the word walls. Well, first of all, obviously you can't see the words, but, this is a science one and the STEM word wall back here, but I don't see any math on it. I'm not quite sure the purpose of it, but right here, I noticed under R, it has relative density. Well, that's in the 5th grade TEKS, but what is the main concept? What is the concept? It's density. It should be under D, but it's under relative density. So, there's so many nuances of how we can do things incorrectly and can mislead students. And the idea, word wall is supposed to help build academic vocabulary after they learn the lesson. So the other things that we've talked about is a huge problem, and Michael brought it up when we were over there with is taking generic ideas, sometimes best practices, and thinking it is K-12 in all disciplines. You do not teach the vocabulary before you teach the concept in math and science. That is a reading idea. That is not math and science. And so, be careful when you get these high-paid consultants who say, do it this way or that way, and they're telling you it's K-12 in all disciplines. And that is simply not true for math and science. Math and science have their own best practices, and that is what our job as math and science teachers is to learn what those are. And that's what we try to do here. So that's why I went back to what Donna was saying, best practices in math and science, known to the unknown, concrete to the abstract. So making it concrete by taking this outside or doing these models, etc., does that. And as Donna said, that was an aha moment for her students, or at least it's too.
Yeah,
Yes,
we both do.
Craig?
I like how when earlier you asked, I think it was Donna, could we have labeled this X or P or Q or T? And then you said that letter varies, so we call it a variable. So we got that definition and said it varies, so that's why we call it.
That's why it's called a variable. So let's talk about best practices then, because I'm not gonna have time to finish this lesson. We'll continue this lesson next time we meet, which is I don't know when.
March of
And this is
15th.
a good stopping place right now. If I go any further, then, next March, I need this to get your minds going again for next time, okay? So, I'm not gonna put
I
up,
have a comment about, and this is not, this is about reading, this is about what you just said on reading. And, you know, teaching vocabulary, to me, before you read a story, and I'm asking, I guess, fifth grade teachers or any teachers what you think about this. One of our teaks for reading is they have to be able to define words in context. Teaching a set of vocabulary before you actually read the story totally negates them
That's
having
correct.
to figure out
Yes.
words in context. I mean, what does this word mean? Use those contextual clues to figure this out. So is that really then a best practice even for reading?
I don't pre-teach.
I don't do it either.
I don't pre-teach.
They need to
So-
learn it in relation to the content.
That's right.
Yes.
I mean, because
Otherwise, it's just memorization.
we have so many, I mean, multiple meaning words too.
yeah.
Well, you know what, the
So-
conversation came up with your curriculum lady?
Who's asking?
Yeah, I said, well, I don't know reading, so I'm not gonna try to pretend like I know how to teach reading. But then we started thinking about inquiry, and I said, well, why couldn't they learn a concept by inquiry? Do you remember
It was
which
main
one?
idea,
What?
main idea.
Oh, main idea, right, yeah, why couldn't they learn the main idea by reading a small paragraph and say, you know, what do you think this says in one sentence?
Well, that's exactly what we do in reading, you know, I mean, we
Right.
don't say, you know,
This
we
is-
may
this
give
is
them
the
some
main idea.
guidelines or parameters and need you to think about who or what the most important thing is, or give me the, you know, what you think this is about in 10 words or less, but we don't, I wouldn't pre-teach main idea. I mean, I think that it,
It's okay, I'm just.
yeah, no, I know, I was just
I
saying,
mean,
but.
we have seen so many problems by getting ideas about, that are K-12 and all disciplines, and you just don't do that. I don't care what some big name person says, and sometimes things will be misinterpreted, you know, like from Marzano.
I
mean,
was just
he's a
thinking
generic.
Marzano, that's
Yeah,
exactly who I was
Yeah,
thinking about.
and I know Kilgo does it, and I don't know, some other ones that are in there, and they preach this, you know, some nice ideas, but they are not math and science applicable. Some parts are, and some parts are not, so, you know, don't be fooled by this. I mean, know your discipline and your best practices so that you're not fooled by this,
Thank you
and
for
you don't
saying that.
undermine your students'
But
learning.
that's where I was going. I was just fixing to bring that up. You have to watch the consultants that come in, except for us. You have to watch that come in because they do tend to give this paint with a broad brush that, you know, doesn't fit everything, okay? Yes, sir.
I'm hearing what you're saying. You have this stem of a question, they have some words in there that you don't wanna pick out, that are kind of, you know, that they don't understand. How would you go about pulling those words and kind of going, I hear what you're saying too, about not pre-teaching it and using it in context, but how would you pull that word out before you answer this question? I want you to look at these, you do with a story, and you take a, what do you call it, a picture walk, you know, as you're going through the story. How would you pick this word out and teach that?
Okay, that sounds like reading, and I don't know a thing about that, but
Well,
I'm gonna tell you about
it-
science.
It applies to
Let me
science.
tell you about science, okay?
Okay,
In general, if you're, well, I wanna go back to what Browning said
okay.
earlier. She said something about teaching a calculator as a direct teach, okay? So here's the other, what research says. In general, now there's some, you know, there's some exceptions, but in general, if you're teaching a skill or a process, you use a direct instructional model.
Okay.
But a complete direct instructional model, because a lot of times we see partial, you know, direct teach. And direct instructional model works, we know that, but it's usually not done with the input and modeling, the guided practice, and the independent practice. And independent practice is not homework. Independent practice is where the students are doing independently and the teacher is monitoring them independently, okay? So that's direct instruction. If concepts are in science, are best taught with inquiry. So with inquiry, the student experiences the concept first, they develop their own operational definition of how that works, that concept works, I'll put it in general. And then in the whole group discussion, so they're doing this in their small group, like in their labs, all right? And the lab group should never be more than 4 in science, ever. Sometimes they should be 2 or 3, okay, as small as that. Then, after the students have done this, and there's lots of student talk, and that's what you saw in this instruction, is there was not much teacher talk in this lesson. It was mostly student talk in either amongst individuals or even as a whole group, that the students were explaining their thinking. Because we don't know if you understand something if we don't hear you say it, if we don't hear you explain it. And it's, you know, any questions is not a question. Understand it, everybody understand it, is not a question. You know, that's a waste of your time and theirs too. You have to know individually whether they do. So with inquiry, then, that would be in the explore, all right? And so they develop their operational definition at the end of the explore, and the students are explaining their understanding of it during the explain. This is not teacher lecture. The explain part of a 5E is not a teacher lecture. It is the students explaining their understanding and the teacher perhaps making some clarification. And then after they understand the concept, then the concept is named with the academic vocabulary. Okay?
And that's basically what we are doing today. We're stopping in the middle of it, so we're not through with the content. We have not finished the objective of this lesson. We will finish this in March, so don't immediately miss March, because then you won't know, okay?
Can I say one thing?
Hang on. So this lesson is actually a 5E. So what pieces of this lesson have we gone through in that 5E? What's the first E? Engage. So,
And it does not mean define vocabulary words like I've heard some teachers tell me they do for the engage.
yeah, no. So what did we do to engage?
We play with the rods.
We played with the rods, and I reviewed you of what we did last month. I'll let you do 2 of those, what we did last month. Get your brains going in gear again. What's the next E?
Explore.
Explore. Have we been doing that?
Yes.
What's the next E?
Explain.
Explain. Have we been doing that?
Yes.
And sometimes explore and explain rock back and forth in math. Yeah.
And they do in science too.
So what's the next one?
Elaborate.
And we're not there yet. Okay, we're stopping at the explain, explore. We'll elaborate next month, and we will assess or evaluate next month.
And the elaborate means that you are deepening the student's understanding or broadening the student's understanding of that concept in different contexts, etc.
And in explore, explain, which are together in my mind, explore, explain, then we're clarifying misconceptions as well, because we don't want the kids leaving with any misconceptions. So if I hear a misconception, y'all did a good job of doing it yourselves, you know, y'all were confused about something that group did up there. So we clarified some misconceptions there. We talked about slope and some misconceptions there. We talked about the X and the Y, which one's dependent, independent, and slope, you know, it's rise over run, not run over rise. We've clarified a whole lot of things in here for, and that will continue. That will continue with the next March
I
thing.
think Claudette had a question.
Claudia had a statement.
Yes, I had a statement. I was gonna save it for when I'm at what my GP, but I don't know if this might be helpful. We had a professor come in and she had developed a vocabulary program. She had seen so many lessons that took so long because kids did not understand the academic vocabulary. So the teacher could not get to the concept of the lesson because we were stuck on whether math or science, Doc. I'm just saying.
Okay, well then we don't want to hear about it.
Well,
I do.
Well, I
I
was
want
just-
to know if this person's right or wrong.
Oh,
Well-
if it's not math or science?
Well,
It was
what she
generic.
wasn't targeting math or science. She was just saying, when you get kids who are 2 and 3 years below, which we do, and they don't have any prior knowledge from before, then she was advocating that you do some vocabulary exploring before you go, remember Dr. Jurgensen, before you go into a lesson, so you don't spend what should have been a lesson on some kind of concept stuck because they can't get past this word they have no experience with. And so she did advocate some, I don't know if she called it pre-teaching, but there was some review, like the next day, we're gonna be talking about this concept, washable markers, than they did something the day before to prepare them to be able to embrace that concept.
But
That's all.
if they don't have that prior knowledge, if they don't have that conceptual understanding, having a memorized vocabulary is useless. It's a waste of their
It
time and
wasn't
it's a waste of.
memorizing, it was just introducing them to have some awareness of or experience with. It wasn't memorization, it was just
Well,
some,
how do you
see
do
the
it
word, see the word. They've never seen the word before. So she had these words that they could see and engage with, not memorize that. I'm just
How do
saying.
they engage with it? How can they engage with it if they don't understand it?
Well,
It's just still another
it was the
word.
beginning of just seeing the word.
Is
Just
this
being,
5th through 8th or these K through 4?
Can you give us an example?
Like if it's 5th through 8th, it doesn't work. K through 4, it does work.
yeah, I think it was.
Kinder,
the younger
first,
grades.
second, they need to see
I
the
just was
word.
saying that, I'm not taking a position, I'm just sharing that, because I wanna really talk to our teachers before, because we had a lot of conversations when she brought that to us,
Right.
and sometimes when we leave this meeting, we have to go and get on the same page with, at our school,
Right.
how we're gonna communicate this, so I kinda wanted to make sure that I talk with Chung, please.
Okay, I'm gonna go back to what I said. If students come in with a lack of background, and you can check with one of mine here, Kimberly, if they don't understand the concepts, then you go back and you teach it.
Yeah.
It doesn't make any difference if they're supposed to be here in that grade level, and they're down here with their conceptual understanding, they can memorize stuff, but it's useless. You're better off having them go back and understand conceptually, and you do this with the hands-on, the concrete, the known. You know, you're still following the best practices, and then you're building them up there. And even if they don't get here, it is better for them to at least build this part
Absolutely.
than to start up here. And, I mean, so many people think science is useless because all we have done is have a memorized vocabulary and to put them in scenarios that make no sense. We have not built that conceptual understanding. And
So then can I
Kimberly,
clarify what,
is that exactly what I told you? Go back and teach it if they don't know.
what I hear, so what, to me what you're saying then, they get stuck, they're not ready for it, you go back.
You bet.
So it's not a vocabulary thing, they can't grab that concept.
No.
So we
It's a
talked
concept,
about
it's
that.
part of the concept.
Yeah,
It's all, the vocabulary is only a name for the concept.
sure, sure,
The idea is they have to understand it.
sure, sure.
And if they understand it, then it's easy to name it,
I'm with you.
you know, but it takes time, just like it took time in here to understand the concepts. And that is so critical, you know, for everybody, you know, teachers and principals, that it just takes time. And your time is so precious, you can't be going off on rabbit trails in different directions. You have to stick with the TEKS. I mean, I don't know the math TEKS, but I know the science TEKS. And they are taken from the national standards, and if you stick with those science TEKS, except for a couple of them, there's a couple of problems with 5th grade, you're gonna be fine. And if you're teaching 8th grade and they don't understand 5th grade, then you better go back and teach those concepts.
Because it won't do anything if you don't.
That's right, it won't.
So I want to talk just a few minutes about best practices, what, Kim? So, best practices in here today, what have y'all done that were best practices today?
Started with concrete.
Concrete.
Started with concrete.
And then we went.
Wait a minute, what's concrete? Okay.
We started with the actual Cuisinart rods. It wasn't even pictures. We had the rods we could manipulate. So
Right.
there's the
Because-
difference between because to me,
No,
It's
not
not about
to you,
pictures to
and
rods.
you are absolutely, it's not
Thank
to
you.
you, it is in general. This
Okay.
is